Hi, today's lesson's on graphing polynomial functions. So the first thing we need to do is classify polynomial functions, because once we can classify them, we have an idea of what they look like and how we should graph them and such and such. So first thing we're going to do is write this in standard form. What standard form means, start with the biggest degree or biggest exponent and then count your way down. So for example, this one, the biggest one here is 2x cubed. So 2x to the third power. Next one would be 3, then 2, there is no 2. Next would be 1, so negative 4x. And then 0, which is the constant or the number by itself. And that's it. Now, as you can tell, this one is missing an exponent, which is x squared. That will come into play later. So now that we got standard form, everything is focused right here. This is called the leading term. On the leading term is a leading coefficient, which is 2. That is your leading coefficient. Next thing is our degree, which is the exponent. So the degree is 3. And the last thing we're going to cover is the number of terms. Number of terms is how many separations by addition and subtraction are. There's 1, 2, 3 terms. And that's it. So because of this and using the leading term, we can understand how these things should look like and how they should end. And so for this, I'm going to go ahead and draw you a nice little handy chart that will help you get through all of this. And it's all based on the leading term. That's it. So at the leading term, we got 2 parts. So go ahead and draw this. So we have 2 parts to the leading term. We have what's degree is, and what is the sign of the leading coefficient. So if the leading coefficient, it's either going to be positive or it's going to be negative. And the degree is either going to be even or odd. So using this, we have an idea. So if it's even, it makes like a U shape. So it's going to go up, do whatever curves, and then end up. So the way we describe this is we say it rises on the left and rises on the right. So same thing, if it's negative, that reflects things down. So it's going to be down and down. So the way we say this is we say it falls left and falls right. Now, odd always starts low and ends high if it's positive, because positive is increasing. Starts low, ends high. So this one falls left, rises right. And negative, of course, would be the flip of that. So starts up, ends down. In other words, if you start high and low, that's decreasing, so it's negative. So this one says rises left and falls right. And so this chart will help you with the rest of this lesson. So let's go ahead and find the end behavior and describe it. We're just going to use words to describe it, nothing else. So notice this is in standard form. So all we have to do is focus on this part right here. So if we take a look at that, 1, it is negative. And we see that 4 is even. Since it's negative even, we look to our chart. So negative even means its end behavior means it falls left and falls right. And that's all we have to say. So it falls left and falls right. So same thing with this one. We look at the first term, make sure it's in standard form, which it is. Focus here. This one is negative and odd. So since it's negative and odd, we look to our chart. So negative, odd would be rises left, falls right. And that's what we write. Rises left, falls right. Go ahead and try this problem. Try this problem. All right, using the same chart, we could actually graph the polynomial function, at least sketch a graph so we have an idea. So same thing, we look here. It is positive, even. So if we look at our chart, positive even should start high, do some stuff, and end high. So rises, should ends there. So the way we do this is pretty easy, but 4 is the most it can cross the x-axis. So if we draw a line, we know it's going to start here, and then it's going to end up here. So if we just go from here and cross the line 4 times, we should end up with a good sketch. So 1, 2, 3, 4. And if you notice, we get rises, rises. So same thing with this one. This one is negative, odd. So same thing, draw a line. If we look at negative, odd, we start up on the left side. And so now we're going to cross 5 times. 1, 2, 3, 4, 5. And there's a pretty good sketch of this. Now, in reality, it's not guaranteed to cross 5 times, but for a sketch, it's pretty good. Does the trick. Go ahead and try this problem.